Again, I repeat, so for the very first question, it says, for the system of forces shown in figure 1, answer the following questions. Draw the triangle of forces. تمام? The triangle of forces تاخذونه من السؤال نفسه. The first thing you do is draw your y and x axis وبعدين ترسمون الforces at the origin point. So you're going to draw your x and y axis فهاي ال y axis وهاي ال x axis, and then you will draw your forces at the origin. This is our first force over here, which is 26 kilonewton. وبعدين عندنا our second force, which is at the bottom here. Oops, which is at the bottom here. All right. This is our second force, which is 30 kilonewtons. إنزين معطينا هني الانجل is 30 degrees وهني معطينا التراينجل اللي هو بهالشكل 12 and 5. Right? So once you draw this خلاص مو لازم بعد تطالعون الحين الصورة هاي. انتوا تعتمدون على your own drawing, يعني just depend on the drawing that you have drawn and use that to solve. Okay, so make sure you are drawing it correctly. This is what we have. The first thing we need to analyze هني هو هاي 12 and 5 triangle. فإذا عندنا 12 and 5 triangle, it looks like this. What does this mean? This means that هني عندنا 12 on this side and 5 on this side. This is a right triangle. All right? فبترسمون the triangle the same way it is. And this angle over here, زين نسميها ثيتا مثلا. هذا الانجل we can determine it using SOHCAHTOA. تتذكرون SOHCAHTOA. زين SOHCAHTOA شو اللي هو opposite to adjacent اللي احنا عندنا اياه. This is the opposite side. This is the adjacent side. فنعرف ان tan theta is equal to opposite, which is 12, over adjacent, which is 5. معناته theta is equal to tan inverse of 12 over 5. معناته theta is equal to 67.38 degrees. زين this is your angle here. So now you know that this angle لأن تشوفوا it's the angle with the horizontal. فمعناته it's the angle of this force with the horizontal is 67.38 degrees. زين before even moving on and solving the remaining question, you guys have to understand the angles, what they mean. What do they mean, all of these angles? You should be able to analyze all the angles and manage to find all the angles you need. Then later on, when you draw the triangle, you're going to be using these angles to analyze them. فنعرف إن هني عندنا right angles. هذا right angle وهذا right angle. فنعرف إن هني بيكون 90 minus 30, which is equal to 60 degrees. زين فعرفنا إن هذا الانجل بيكون 60 degrees ونفس الشيء على الانجل اللي فوق it is 90. This angle over here it's 90 minus 67.38 زين which is 22 point ما كتبت المكان 1 second. It's 22.62 degrees. 22.62 degrees. All right. So this is how you have to analyze it from the beginning. اعرفوا كل الangles وين هم عشان بعدين when you're gonna do your triangle you know how easy it is to do it. Again we're gonna draw the triangle of forces. What is the rule for triangle of forces? You need to connect the head to tail, and then again this head will connect to the tail of the other force. Now there are many ways you can do this. Let me copy paste this down. هني. Okay. So there are many ways you can do this. For now, I'm just going to remove the angle, a calculation at least for the angles كذي. All right. كيف تقدرون تسوونه؟ ممكن انتوا تحركون هذا تجيبونه هني. زين. This is correct if you want to do it this way, but I do not recommend doing that. How should you do it all the time? دائما خلوه بطريقة إن عندكم one tail by itself at the origin. ليش؟ لأن later on you will see that when we are doing an analysis, it's going to make it easier to find your resultant angle. I would move this force over up here to the, okay? لأن الحين لو تلاحظون resultant force اللي بيكون عندنا إياه. If I just make this a bit larger. resultant force بيكون move this angles من هني من origin from the tail to the head. Alright? This is how you draw it. Tail to head of the red force connected to the tail of head of the second force, the 30 kilonewton force, is equal to the tail to the head of the resultant force. هذا هو. And then this is how you will draw your resultant force اللي بنسميه R, which we are trying to find. Alright? فلو تلاحظون الحين عندنا our force triangle. The force triangle looks something like this. So عندنا هني الريد وعندنا هني البلو تقريبا يعني، وهني عندنا البيربل. Okay, this is how it looks like almost يعني. زين what do we need to determine now? All of the angles. طبعا احنا ما عندنا كل الانجل ولا انجل هني واضح directly، ولكن first we look at the sides that are given. So احنا عندنا هني 26 كيلو نيوتن وهني عندنا 30 كيلو نيوتن. بتروحون بتسوون هني another axis. Okay, at the point اللي سويتوا فيه ال intersection. فهاي 26 كيلو نيوتن is over here. Alright, بتسوون a new axis. Now this axis هني إذا you extend it a little bit بتلاحظون شيء. بتلاحظون إنه you're forming basically a right triangle at the bottom هني. Okay, so this is 67.38. Let me just make it a bit smaller. 67.38. هذا الانجل هني. فنقدر احنا نطلع هذا الانجل اللي هني which is this angle. ليش؟ لأن هني عندنا right triangle. Okay? But let's say this is angle alpha مثلا. Okay? هني هذا الانجل إذا رسمنا هالتراينجل بس على صوب صغير هني كذي. This is right. This is alpha. This is our alpha. Okay? Alpha is here. إنزين. ونعرف إن this angle is 67.38. فبنعرف إن هذا الانجل is 90 minus 67.38 rule of triangles. إنزين. So it's equal to 22.62. All right. So we know that alpha is equal to 22.62. تمام. Another way you can look at it هذا القانون شو اللي يسمونه alternate interior angles اللي هو حرف الزي. يوم يكون عندكم حرف الزد بأي طريقة يعني if it was in this way. Okay. صار n بس it is a z يعني upside down. الانجل اللي عندنا هني whatever angle we have here is equal to the angle here. ف if you look at this line هني هذا هو ال z or the n إنزين اللي عندكم إياه. ف it makes sense إن this angle 22.62 is equal to our alpha. Okay, this is another way يعني you can simplify do it directly الانجل بدون triangle. بس إذا ما تقدرون the simplest way إن تسوون الأكسس مالكم وترسمون الأكسس وبعدين you would determine the angle using your triangles. So now that we have found alpha is 22.62, let us find this angle over here. Let me use this color. This angle over here. And then let's call it beta. Remember, when we look at the original angle, the original force is already making what? A 30 degrees with the vertical. And then فهني this axis, again, it is going to be making 30 degrees with the vertical. So beta is also equal to 30 degrees. فمعناته هذا الانجل total زين this angle let's name it خلصوا الاسامي اللي بسميها let's not name it anything but call it beta plus alpha. ليش؟ لانه هو هذا الانجل total الحين لو تبون تشوفون الانجل من ال blue all the way to the red line it is equal to beta plus alpha. فمعناته it is equal to 30 degrees plus 22 alpha, we found it to be 22.62 degrees. معناته the total angle is going to be equal to 52 52.62 degrees. فهذا الانجل طلعناه 52.62 degrees. Alright? So now let's analyze just this triangle. طلعنا الانجل اللي between them. Remember that when you have two sides and the angle in between, معناته you can use cosine rule. Right? So if you have two sides and the angle between them, just know that you are going to be using cosine rule. وأكثر الأوقات الforces, this is how you're going to do the analysis. You're going to find your two sides, your two given forces يعني. والangle between them is what you're going to try to find out اللي هو هني. And then you could just apply cosine rule. If you remember, cosine rule is هذا r squared is equal to then the first side squared plus the second side squared اللي هم 30 و 26 minus 2 times the first side times the second side times the cosine angle between them اللي هو 52.62 degrees. Then you can simplify this. You're going to find out that r squared is equal to 628.92. معناته r is going to be equal to, just do the square root on both sides to cancel the square. R is equal to 25.078 كيلو نيوتنز. طالما احنا الفورسز من البدايه قاعدين نتعامل ويا كيلو نيوتنز معناته resultant force will also be in kilo newtons. All right? And now we found our resultant. First of all, the question was only asking to draw the triangle of forces. We already have done that over here and over here. This is our triangle of forces. And then B was use the triangle rule to determine trigonometrically the magnitude of the resultant force R. فهذا اللي سويناه هني using cosine rule طلعنا resultant R. Part C يقول determine the direction theta of the resultant force with respect to the x-axis. Okay. So what does that mean? Let me take this drawing again one more time. Okay. So this is for part C. خلنا الحين we remove everything else هني من ناحية الانجل. هذا الانجل we don't need. This we don't need. We have already found this total angle, but we're not going to need it. We need to find this total angle of the resultant force اللي هو بيكون من هني من ال positive x-axis all the way to the resultant force. This is your theta, all right? It starts from the positive x-axis من صوب ال x لين ال actual resultant force. تمام؟ So نعرف إن هني 90 degrees. Well, not that big, it's in. This is 90 degrees. Right? So we know that this is 90 degrees. هني already طلعنا الangles من قبل 22.62 degrees. This is why I said from the very beginning, analyze your angles, it will simplify later. وهني عندنا 67.38 degrees. All right? So which angle now is remaining? We need to find one more angle. We need to find this angle اللي هو بين الأحمر. One second. We either need to find this total angle or the angle small هني. هاي الانجل كامل ما عندنا إياه. This is the angle we need. لأنه we know that this angle, if we call it theta, أو استخدمنا theta already, let's call it gamma. زين. We know that theta is the angle that we need to find is equal to 90 degrees plus 22.62 degrees plus alpha or gamma. زين. Plus gamma. هذا كامل, it will give you the theta angle. So how can we find gamma? Again, we're going to use the same exact triangle that we used earlier. And then, because where's angle alpha or gamma here? This is the angle. Angle gamma between the red and the purple. This is angle gamma. Okay, so we can use this triangle to find out what angle gamma is, because we already have found our resultant force. Our resultant force was 25.078 kilonewtons. فعندنا all the sides. We have one angle, so we can simply use sine rule here to determine gamma. So how do you use sine rule? The best way to do it is whatever المجهول يعني اللي تبون تحصلونه, whatever the variable is, we will put it first. So sine gamma divided by the side that is opposite to gamma, which is 30, is equal to the sine of Now, which angle do we have? We have this 52.62, so sine of 52.62 divided by, again, what is opposite to 52.62? The resultant force, which is 25.078. And then you solve for gamma. So sine gamma is equal to 30 sine 52.62 divided by 25.078. معناته gamma is going to be equal to sine inverse of 30 sine 52.62 divided by 25.078. Okay? You just put that in the calculator. Gamma is going to be equal to 71.91 degrees. So we have found our value for gamma, all right? We have found our value for gamma. But remember, this isn't the actual final answer that we're looking for. We are looking for angle theta, and we are looking for the angle of the resistance, of the resultant, sorry, of the resultant force. أخربط قاعدة حين electrical ويا mechanical. إنزين، فعندنا هالإكويشن. الحين حصلنا الجاما. الجاما is 71.91 degrees. So once you do all of this addition, you're going to get your theta is equal to 184.53 degrees. Okay? And that's how you will solve this entire question. حد عنده سؤال عن أي شيء سويته لين الحين؟ This should be an easy question to solve. It's the most basic form. Again, if you get any two forces, make sure when you're doing the alignment, and then you're making the alignment in a way when you find your tail, your resultant will be placed at the center of the origin. عشان يوم تبون تطلعون الانجل ثيتا مع resultant, it will be much easier that way. Okay. خالد تفضل عندك سؤال.
Yes. بيتا 30 شلون طلعتها؟
انزين حلو. فالبيتا is the angle of the blue force with the vertical. Okay, that is what the angle beta is. It is the angle of the blue force with the vertical. إذا رحنا للoriginal free body diagram اللي رسمناه, we already have the angle of the blue with the vertical. The angle هني is equal to the angle beta. This angle over here, it is also equal to beta. لأن it is the angle between the vertical line and the blue force. Does that make sense? فعشان كذي هني حصلنا نفس الشيء.
It's okay, thank you.
No problem. All right. Can you explain the gamma part again? No problem. الجاما هني. Okay. So again, we are trying to find وين راحت؟ هني. We're trying to find theta. زين. We're trying to find all of theta. So theta is going to be this entire angle from the positive x-axis. We know this value over here is 90. We know this value over here is 22.62 من البداية. We determined it. And the remaining part is this gamma, which is the angle between the red force and the resultant force, which is the purple force. So using the triangle, this is going to be our gamma. So gamma, we can apply sine rule since we have an angle over here and we have all the sides. We can use sine rule to determine gamma by applying sine rule. Since gamma is the value that we are trying to find, so we're going to put sine gamma first because it will make it easier for calculations later. So sine gamma over the side that is opposite to it, this is what sine rule is, over the side that is opposite, which is the 30, is equal to the sine of what's the other angle we have, which is 52.62, divided by the side that is opposite to it, which is over here, 25.0. So this side is opposite to gamma, and this side is opposite to the 52.62. So we divide it by r. Okay, so once we divided this, we just simplify and solve for gamma. Once we have solved for gamma, this isn't our final answer because we are trying to find theta. Theta is equal to 90 plus 22.62 plus gamma. So we substitute the value we found for gamma into this equation and we find theta. All right? Tamam? Okay, let's move on to the next question. So this was question 1. Question 2 is going to be a moment question. So this is the question that we have. The member in figure 2, this is figure 2 over here. The member in figure 2 is subjected to a force F of 6 kilonewtons. If theta is 45 degrees, answer the following questions. Okay? The first thing we need to do is calculate the moment of the force F equal to 6 kilonewtons about point A. Again, أول step you guys should always do to make it easier for you, redraw it in your own way even if the question does not ask, لأن بتسهلون التحليل بعدين. It will be much easier to solve. So it looks something like this roughly. So this is A. Point A is at the bottom over here. This is point A. And then this is 6 meters. And then you have somewhat of a curved structure like this. And then and we know that this radius is 1.5. And then فنعرف يعني من هني, we'll get to that in a bit. We have a force over here, right? And the angle theta is over here. هذا هو الانجل theta which they gave us already to be 45 degrees. في السؤال معطينا theta, if theta is 45 degrees, and the force F is 6 kilo newtons. Okay? So how I usually draw my diagrams is anything that I have given to me, I put just the value of it directly. I don't put F equal عشان أعرف إن I already have this value. You guys can do it in whichever way you like, but I do it this way عشان أعرف شو المجهول وشو اللي عندي إياهم، شو المعطيات. تمام؟ So let's look at this the distances that have been given. So we have been given that this is 6 meters from up here all the way to the bottom. This is our 6 meters. And they gave us that the radius of this curve is 1.5 meters. Okay? Remember, radius is basically any point from the center to any part. To any point on the circle itself. فمن هني لين هني بعد it's 1.5. ومن هني لين هني بعد it is 1.5. Okay? So in other words, if I redraw this again, so in other words, خلصنا الحين احنا من هذا drawing. We have gotten all the values that we want. So this will turn into this 1.5 and 1.5. We could just add them up and write the full distance to the force now over here instead of it like this. نقدر نحط لنا هني الحين distance from here to here. This distance is 3 meters. It's just 1.5 plus 1.5. تمام? So we know that this is the distance of 3 meters. So we have found all the distances now. We have analyzed the distances. Let's see what the question wants. We have drawn our free body diagram. Let's see what the question wants. They want us to find the moment of the force about point A. So point A is at the bottom here. Okay? This is point A. So we need to find the moments about this point. What do we need for a moment? Just a reminder. Just going to make this smaller and take it up here. Okay. So what was the equation for moment? The moment about a point, the moment about any point A is equal to the force times the perpendicular distance. All right? So here we have the force, which is 6 kilonewtons. And then let us break down this force into its components. How do we do that? So we're going to have a force that is going to be like this, vertical, going downwards. And we're going to call this Fy, then it's in the y direction. And we're going to have a force that is going to the right, and we'll call this the Fx direction. Remember, components of a force will always make a 90-degree with each other. And you can break down this force into its components. The reason we do this is so we can simplify, so we can find our perpendicular distance for each one much easily. Okay? Then now, if you notice, Fy, what is the perpendicular distance between the force Fy and point A? It is the 3 meters over here. This is the perpendicular distance. Let me actually just highlight it. So it's this distance for Fy. This is your perpendicular distance for Fy. And for Fx, this vertical 6 meters is your vertical perpendicular distance. Okay? So now we can say that the moment about A is going to be equal to Fy, I'm not going to put our Fx, times the perpendicular distance of 6 meters, because that's its perpendicular distance, and Fy of 3 meters distance. تمام? The reason I didn't put the signs yet, first, when it comes to moments, you have to assume a positive direction, just like we have assumed, we assume in forces, and then later on you'll see in the ladder as well. So basically, we're going to assume clockwise. I usually always assume that clockwise is positive, all right? So any clockwise moment is going to be positive. How do we know if they're clockwise? It's very simple. All you're going to do is this. You're going to take a line from here, and you're going to go towards your moment. So this is basically in this direction. Okay, so we know that this is in this direction. This is a clockwise moment, so this is positive for Fy. Same thing again, we're going to do for f of x. We're going to draw a line from the head, from where the arrowhead is, towards A. So it's going into this direction, all right? So again, this direction, which means it is a clockwise moment. So it's going into this direction, which is a clockwise moment, so it is positive as well. Okay, so positive. That's how you will determine your directions when it comes to moments. So it's positive. But now let us try to find fx and fy. Okay, there is a shortcut to this, but I will explain the full concept, then I will explain the shortcut. If we draw the triangle over here, so this is our fy, and then this is our Fy and Fx, and this is our force F, which is 6 kilonewtons. And then 6 kilonewtons. Remember, you can move around the forces. Yani this is the equivalent of doing it like this and connecting the triangle, okay? If I'm being very accurate with my sizes, then this actually has to connect. Yani if this was accurate, this is what it would look like. So this is going to be this force over here. And then when I move this over here, it's going to close the triangle, okay? This is the whole idea. So هني عندنا fx وهني عندنا fy. Fy over here. And we know that this angle given to us is 45 degrees. Remember, the angle is a horizontal angle. This was from the question. This is 45 degrees. So we know that this is 45 degrees, our theta. We apply SOHCAHTOA. SOHCAHTOA for each side. زين? So first we need to find our fx. زين? Remember, our fx, if we're looking at the 45 degree, this is our adjacent side, this is our opposite side, and our force is hypotenuse, and your force, your normal force, is always going to be the hypotenuse. So keep that in mind. If this isn't your hypotenuse, know that you are doing an analysis in the incorrect way, and I'm talking about in the case when you're doing components, when you're finding your fx and fy. And then, so again, if we want to find fx, we have given the hypotenuse. So we're going to be using these equations that have the hypotenuse, either the sine equation or the cosine equation. Then we are given the hypotenuse. And then, so for f of x, we're using cosine because it's an adjacent. So cosine of 45 degrees is equal to adjacent, which is f of x, over the hypotenuse, which is 6 kilonewtons. Okay? So if we rearrange this equation, we take this a bit to the left. So if we rearrange this equation, we're going to get f of x is equal to 6 cosine 45 degrees. So f of x is going to be equal to f of x is equal to 4.24 kilonewtons. 4.24 kilonewtons. Okay? This is what you will get. Same thing again. We're going to do trigonometry. عشان we solve for fy. So this was for fx. What about fy? Fy is opposite, and we have the hypotenuse, so we're going to be using the sine. So sine of 45 degrees is equal to fy over 6 kilonewtons, which is our hypotenuse. Okay? Rearranging this equation is going to give us fy is equal to 6 times sine of 45. So fy is equal to 4.24 kilonewtons as well. And it makes sense because the angle is half of 90. It's 45 degrees. Sine of 45 is equal to cosine 45. All right. المهم, this is how you get your fx and fy using the triangle method the appropriate way. The shortcut would be this way. So fx is equal to, and fy is equal to, directly, you're going to write it this way. Fx, if we look at this triangle, or if we look at just the forces here, the way they're presented. So Fx is the one closer to the angle. It is adjacent to the angle. So Fx is adjacent. All right. Since it is adjacent, we are going to do cosine, because cosine is for adjacent of 45. And we're going to multiply the 6 kilonewtons force with it. So it's F cosine 45. All right. F cosine 45, which is equal to 6 cosine 45, which is equal to 4.24 kilonewtons. This is the shortcut of how to do it quickly without doing the whole triangle. Fy, again, Fy, if you look at this force Fy over here, this force Fy is away from this angle. It's not next to it. So you could say that that is the opposite of it. It's not the one adjacent to it. So this Fy is an opposite. So since it is an opposite, we're going to use sine of 45. Again, it's going to be F times sine of 45, which is equal to 6 sine 45, where in this case it's also 4.24 كيلو نيوتنز. فعلى راحتكم تبون تسوونه بطريقة الشورت كات أو تبون تسوونه بطريقة يعني the shortcut is basically a derivation of this but in a faster way. Okay? So now we can find our moment about A. So moment about A is equal to f of x, which is 4.24 kilonewtons, and then times 6 meters, plus f of y, which is also 4.24 kilonewtons, times 3 meters. So ma is equal to, you plug this all into the calculator, you're going to get that ma is equal to 38.184 kilonewtons meter. Okay, ليش؟ لأنه we are dealing with kilonewton forces. We're not writing Newton. You can convert it to Newton, but in this case, it's sufficient to write it as here, as long as you make sure your unit is correct. So since this is kilonewton, remember it's kilonewton times meter. So it's kilonewton meter. Okay, and this is the answer for the first part. Okay, this is part A. All right, now let's move on to part B. Okay, let's move on to part B. Let me just take this drawing again over here. Just gonna use this one instead لأنها شخبط أقل عليها, and bring it down here, and we're gonna look at part B now. Okay, again, remember this is just simply 3. This is 3 meters. Then, so now in part B we don't have 45 degrees anymore. In part B it says determine the angle of the force with respect to the x-axis. معناتها it is our theta value, which is basically here. So the force with respect to the x-axis is this value over here, theta. Okay, this is our the angle that we are looking at. For which the moment about point A is a maximum. Also calculate this maximum value of moment. Fair. So part B here, we started part B. So maximum moment. That is what we are trying to find about A, about point A. Maximum moment means either we have a maximum force or a maximum perpendicular distance. However, the force is already given, because remember, moment is equal to force times perpendicular distance. So since the force has already been given, okay, this is a value, this is 6. So we cannot change this force, but we can find the maximum possible perpendicular distance. And that will basically be when this force is perpendicular with point A, meaning the perpendicular distance معناته there is no components. This perpendicular distance here is what we need to find to be maximum. So it is going to look like this. فهذا الفورس انزين I'm gonna change its orientation a bit, because remember we're trying to find theta. We don't know what the orientation is, but we want this distance من هني لين الفورس to form a right angle basically. Okay, so this is our force, 6 kilonewtons. and we want to form a perpendicular distance with the force. Then this way, we are going to have the maximum force 6 being applied at that moment A. Then this is the largest possible perpendicular distance you can have. Okay? So, therefore, we will call this D max. D max. And this is our angle theta that we're going to try to find out later on. This is angle theta. So how can we find angle theta in this case? It is very simple. It might look confusing and all of that, but it is very simple. Let us look at this angle over here as well. Why? Because we can find this angle very easily. Let's call this angle alpha. Then if you notice now, we have formed a right triangle on the left-hand side. We have formed a left triangle and we have a right triangle, sorry, and we have all the dimensions to determine anything. So if I redraw this, okay, so this is our 3 meters. And let's just use the brown color. This is our 6 meters. Okay. So if I draw this triangle, it's going to look like this. This is our 3 meters up here, which is blue. And this purple is our max distance. All right. D max. This is 6 meters, and this is 3 meters. All right. So since we have all of these, we also can find angle alpha, which is here in orange. This is angle alpha. Remember that this is a right triangle. So we can apply SOHCAHTOA to find this. SOHCAHTOA to find our angle alpha. SOHCAHTOA. Then, so what do we have here based on this angle alpha? So these are hypotenuse. This is our hypotenuse. Then alpha, this is the opposite to alpha, and this is adjacent to alpha. Okay, since we have the adjacent and opposite values, we can find tan of alpha is equal to the opposite, which is 6, over the adjacent, which is 3. معناته alpha, you're just going to do tan inverse of 6 over 3, which is just 2. 6 divided by 3 is 2. So alpha طلعناه is equal to 63.435 degrees. All right? So we have found our angle alpha. Now, let us find our distance d max as well, because eventually we're going to need to find this distance v max to multiply it with the force so that we can find the maximum moment, because in the question it said also calculate the maximum value of the moment. So why not? We might as well find it. Very simple, Pythagoras. Okay, since we have a right angle triangle, يعني بنستخدم Pythagoras, which says d squared max, زين يعني d max squared is going to be equal to 6 squared plus 3 squared. معناته d max is equal to the square root of 6 squared, which is 36, plus 3 squared, which is 9. So d max is equal to 40 square root of 45, which is 6.708 meters. All right. This is how you will find your d max and your alpha. Now, why did we find alpha? Then if we just look at this part, and then if we just look at this part now, let me make this a bit smaller and keep it on the side. عشان I use as much space as I can here. Because this is very basic concepts. You guys should know how to analyze a right triangle. If we look at the straight line, and then the straight line at the very top, بكبر as much as I can so you guys can see it. So this is this straight line over here. Okay, this is this straight line over here. Okay, this straight line. We're gonna have the d max, something like this from here to here, and our force is something like this from here to here, making a 90-degree with your distance, your maximum distance. This is 90 degrees. All right, we have found our alpha. This is alpha, which is equal to 63.435 degrees. And we need to find our theta, which is over here. Okay, again, هذا بس يعني this part مكبر. زين, the straight line over here with its angles, but it is magnified. Okay, if you notice, remember the equation for a straight line. the angle is equal to 180 degrees. All right? The angle of a straight line is 180 degrees. It's basically two right angles connected to each other. Yani 90 plus 90, which is 180. So now we can find our angle theta. Why? Because we know that alpha plus 90 degrees plus theta is going to give us 180 degrees. All right? We found our value for alpha to be 63.435 degrees. So plus 90 degrees plus theta is equal to 180 degrees. We rearrange this equation, solve for theta. So theta is simply going to be equal to 180 minus 90 minus 63.435. زين معناتها we found our angle theta is equal to theta is equal to 26.565 degrees. All right. So we found our angle theta, which is the first part of the question. The second part is they said determine the maximum, also calculate the maximum value of moment. So moment about A is equal to the force times the perpendicular distance. And we have already found this. This is equal to 6, which is the force given, times the perpendicular distance that we have found over here, which is d max, all right, which is equal to 6.708. Okay, this is d max because we are looking for the maximum moment. So MA simply equal to 6 times 6.708, which is 40.249 kilonewton meter. Remember that this is in kilonewtons and this is in meters. And then, so it's 40.249 kilonewton meter. Okay, this is part B. So we, again, just to recap, the maximum moment means we need to find the maximum possible perpendicular distance. معناته لازم we find from point A to the point where the force is acting, the perpendicular distance, that will be our maximum possible distance for D max, عشان we find the maximum possible moment. إنزين? And then you're just going to apply your triangular relations. You're going to be forming a triangle هني, doing SOHCAHTOA and Pythagoras to find your values. And then you're going to use the equation of a straight line to determine your theta, depending on the location of theta. السؤال قال theta, or the angle that the force makes with the horizontal, which is this side over here. So for part C, part C now is going to be very easy, and I will show you why. لأن part B it was asking for part B, it was asking for the maximum. Part C is now asking where the moment will be 0, or a minimum basically. So the moment is basically going to be equal to 0. And when is moment going to be equal to 0? So M is equal to force times perpendicular distance. So again, the force is constant, 6 kilonewtons. We cannot give a 0 force. So for this to be equal to 0, we have to multiply this by 0. Therefore, our perpendicular distance has to be 0 as well. So how can we have a perpendicular distance that is 0? This basically means that our, let me actually bring the drawing down and I will show you here. All right. So how can we have a perpendicular distance that is 0? This basically means that this force has to go through the force, the moment, the point at which the moment is being taken. So if I remove this d max for now, then remove this alpha, we don't need it. Remove this perpendicular, we don't need it. I want to keep this to explain a point. Okay, that's it. We don't need this distance anymore, actually. This doesn't matter. We don't need this highlight. We don't need this distance. We don't need this right. I just want to look at the forces for now. Let's say this was max. Okay, so the red one was for maximum. This is for the maximum. So this is the theta maximum. Okay, so here again in the previous question, this is theta max. Okay, the maximum theta for the max, and I mean the theta for the maximum moment to be found. So let us find the theta for minimum now. So what did I say? This basically means that the force has to be going through A. So if I draw this any extension, the force is basically going through A because there is no perpendicular distance you can draw from this force. This is not causing any moment about A anymore, لأن it's going directly through it. And if you notice, this is causing a right angle over here. لأن when you're drawing a line from point A to the force, you're drawing your Dmax distance, which is the same thing, which is your perpendicular distance. So هني اللاين هذا, this is a perpendicular distance between this force, which is also 6 kilonewtons, okay? But now we need to find our theta minimum, which is this angle over here, theta minimum. تمام? All right, theta minimum. Is this point clear? Again, I repeat. احنا طلعنا قبل شوية theta max and the force, and it made a perpendicular, it made a 90 degrees angle with the perpendicular distance of it. Now, when we want D to be equal to 0, we need a force that is going directly through moment about A. So about A, so we need it to go through point A. فمعناته هذا الخط, it is exactly going straight through point A, so it has to form a right angle with the maximum. All right? So this force is for the minimum. So if you look at the angles here, let's do the analysis. Remember that this is a 90-degree angle. This is 90 degrees. So if you look at theta minimum, the total angle, this total angle over here is equal to 90 degrees plus theta max. صح ولا لا؟ لأن if I magnify this a little bit over here, we have the horizontal, then we have the red and the blue line. So we have the blue line going something like that, and we have the red line making a 90 degree with the blue line. So it is something, it is something like this, okay? So we are trying to find, remember, this is theta maximum over here. Okay, because the red line is the maximum. And this is theta minimum. And we know that this is a right angle. So this is 90 degrees. So 90 degrees plus theta maximum is going to give us this total angle for theta minimum. All right? These are our 6 Newton forces. Therefore, that's why I wrote this equation that theta minimum is equal to 90 degrees plus theta maximum. So now we can simply find, since we have already found theta maximum, we can say that theta minimum is equal to 90 degrees plus شنو الثيتا maximum اللي طلعناه 26.565 26.565 degrees. So theta minimum is, just adding these two numbers, it is going to be equal to 116.565 degrees. And that's how you will solve it. Remember, always the minimum and maximum are going to be 90 degrees between each other. All right? They're always going to be the case. Is it clear? Any questions about this so far? حد عنده سؤال؟ إنزين فاهمين؟ ممكن تعطوني thumbs up or something, type in chat فاهمين؟ إذا فاهمين عشان أعرف يعني إن you guys are getting the concept وكل هذا. تمام.
I have a question.
Go ahead. اللي عنده question يسأل. تفضل.
From the start, why did you ignore the half a circle when calculating the forces at a distance?
لأن when we are talking about moment, remember the question, moment is only dealing with a perpendicular distance. إنزين, we have to deal with the perpendicular distance. معناته we don't care about this whole arc. إحنا we don't care about it. إحنا we care about this perpendicular distance here from Fy. That is what we are trying to look at. إحنا we are always looking at the perpendicular distance. نفس الشيء حق Fx, we are looking at this perpendicular distance over here. It doesn't matter the shape of this, how it looks. إحنا at the end of the day, we're going to draw a line that is going to form a perpendicular with our A. So this perpendicular distance over here. And the same thing over here, we're going to be drawing a line that forms a perpendicular distance from the force to point A, where the moment is being found about. تمام؟ For this arc, we don't care about it at all. This was just given because they gave us a radius here, r, and they want you to see that this is also going to be equal to r, and this part is equal to r, so you can find your total diameter, which is 3, or your perpendicular distance for Fy. Tamam? Does that make sense?
Thank you.
You're
Yeah.
welcome. Any other questions? For me, just part B. Again, I will re-explain part B very quickly. فحق part B, again, remember, the moment is just force times the perpendicular distance. زين? Force times perpendicular distance شو معناته؟ معناته إنه we need to find the largest possible perpendicular distance. Why? لأنه we already have the force given. The force is given. We cannot change it. Even if you notice in the question, it says it again. The angle for a force of 6 kilonewtons. So خلاص, هذا constant. We cannot change this force. We cannot change it at all. It's the same. But we can manipulate the perpendicular distance because we can manipulate this angle. زين؟ فالforce we can have it like this, we can have it like that, we can have it in any direction. But in this case, it is asking for the maximum moment. The maximum moment basically means you are going to be drawing a perpendicular line زين, to the force. That is your maximum distance. So this is where the moment is being found about, a moment about A. So we're going to be drawing a line to the force, a perpendicular line, I should say. So it's going to be like that. And it has to make a 90-degree angle because this will be the maximum possible distance for this force of 6 kilonewtons to act all on it. تمام? In other words, يعني ما بيكون عنده components. ما بيكون في components لهالforce. The full force is acting upon A, not components of it. All right? That is the whole idea. Is it clear now, ريان? محمد عندك سؤال تفضل.
بس هذه الافكار اللي ممكن تجي على المومنت.
هذا هو that's the only thing يعني أنا I can think of. بتشوفون المومنت في الفريكشن هناك بعد بيجيلك هالافكار اللي بنستخدمها في الفريكشن. alright. فبنشوف المومنت بعد زياده في الفريكشن هناك بتشوفون شوي كيف يختلف المومنت من هنا لهناك وبنتكلم عن القواعد يعني القوانين المهمه هناك في المومنت من ناحيه دايركشن وكل هذا بعد. فالمومنت بيجيلك في هالسؤال وفي السؤال الثالث اللي هو مال الفريكشن. تمام. انا اكثر الظن اتوقع بيجيكم ماكسيمم من مينيمم حق المومنت لان it's the most difficult part for most people. You are moving the distance. We will have this recording. Yes, الrecording كامل بيكون موجود and I will upload it as soon as the session is over إن شاء الله. وبطرش لكم اللينك حق الrecordings كلها. You are moving the distance because you cannot change the force. Exactly. This force, I cannot change the value of it. So the force has to stay at 6 kilonewtons. However, I am trying to find the angle at which this force will change. And then, يعني this moment, will change. So I can move around this force like I showed you earlier. I can move it around in any orientation, but it's always going to be 6 kilonewtons. But my theta can be from here to here, from here to here, from here to here to here. It doesn't matter. Okay? That's why we have chosen our perpendicular distance, and this is most probably how it will be also in the exam. بيعطونكم الفورس وبيقولوا لكم find the distance. ممكن يعطونكم perpendicular distance and they say find the force. It might be, but this is a more difficult way to solve because that way it will be much more straightforward. Then all you have to do is find the perpendicular distance to the force, but then just multiply this distance with this force over here and you're done. تفضل خالد.
I have a question about B. الحين maximum moment, can we draw the line from the point A للtip مال force الهيد يعني to find the maximum?
بقول لك ليش لا. No, that is not possible. لأن that's actually a very good question. خليني I just copy paste this down here and I will show you why you cannot do that. Remember when you're looking at a moment, زين, the force when it's acting upon a point إذا أنت الحين بدال ما ترسم الدي هني رسمته كذي, this is no longer the perpendicular distance. حتى لو عدلناه هني وسوينا high perpendicular, it is no longer the perpendicular distance. Why? لأن the force is acting on this point. It is not acting at this point. فأنت you need the perpendicular distance from this point, not this point, where the force is acting on. يعني لو خلينا الفورس كنقطة, إنزين, لو خليناها الفورس كنقطة, بيكون بس هاي النقطة اللي هني, highlighted in red. زين لو كان صغير كلش الفورس كنقطة it is affecting this part. This is where it will have an effect on, not this part. This part is just showing the size, the magnitude of how big the force is. But the actual action is happening at this point. عشان شي دايما you have to draw it to the tail of the force. A very good question, by the way. So when you are drawing your perpendicular distance, it has to be to the tail of the force. يعني ذيل الفورس when ما في arrow, there is only a point.
يعني it's always gonna be at the tip, huh?
Always at the tail, not the tip. زين التip
صح.
يعني على الهيد ف it will be
صح.
always at the tail اللي هو المكان بدون السهم. نعم.
Okay.
Always. تمام.
Thanks.
Can we, no problem. Can we change the perpendicular distance like change the angle? Yes, you can, بس they're both related to each other. يعني بعد مرة إذا رديت رسمت هذا هني. If I moved my force, let's remove this. زين. If I moved my force, and it's in this direction, for example. Okay. This is going to be my new theta. But if you notice now, my new distance, maximum distance, is not perpendicular anymore from here. This isn't a perpendicular. لأن remember, it has to be perpendicular with where the moment is. My new perpendicular is going to be something like this. This is going to be my perpendicular distance from this moment. And then, but if you notice now, you cannot calculate this because you do not have the givens, the side. فوايد بيكون معقد الوضع. This way your theta is going to be, you cannot find your theta, you cannot find your distances. So your perpendicular distance will be difficult to find. That is why we always are going to do it in the way where we draw it from the point of the moment itself. Because this is going to be your maximum distance over here. It depends on your theta. And then, so this theta is going to change now because this force direction is going to change due to the perpendicular distance. This is going to be perpendicular. So this is the only theta for a maximum. لأنه when I did the force in that orientation, that d, that perpendicular distance, was no longer my maximum perpendicular distance. But let me use a different color for that. Let's say it is in blue. All right. يعني when I did it like this, okay, this is also a perpendicular distance to the force. Yes. Okay. But this is no longer d max. This is no longer d max. لأن this d, if you notice now, if I rotate this, this is smaller than the maximum possible distance we can find. All right. What about the directions of moment? Oh, directions, we already determined it from the beginning, but you're right again. Yes. El moment, they're all clockwise moments, so I didn't focus on that. But you're very right. Yani if we look at part B, to find the direction, okay, so it's basically in this way. So it is a clockwise moment, so it's positive. That's why I put it as positive. So this is going to be a clockwise moment. So this is clockwise, positive. You're so right. You're correct. The direction of moment should also always be considered. It is a very important part of it. And then, same thing with the bottom one. If you notice here, what is the direction of moment? It is going straight through. Since it is going straight through, معناته there is no clockwise or counterclockwise moment. It's zero moment. And that's what we are trying to find. We're trying to find when the moment is zero. That is why when the line is going directly through it, it doesn't cause any clockwise or counterclockwise moment. It's only zero. Because it's going right through it. You cannot draw a curved line. You're drawing a straight line. All right. Let us take a 5-minute break. And then it is 5:05 right now. 5-minute break. So back at 5:10. And then inshallah, we will start with the friction question. If you have any questions about this, feel free to ask. I'm still going to be here. But I want to take a 5-minute break عشان نشرب ماي نهدي شوي نجمع أفكارنا وبعدين we will start with the friction question. All right. So questions 1 and 2, are they clear? Do you have any questions about questions 1 and 2? لأن خلاص, from now on, I'm not going to go back to them. I'm going to just solve the friction because it takes time. So I want to focus more on that. وبعد the linear equation as well. And for the linear one, it's going to be, I'm going to be explaining it more than what is just for that question required. عشان تعرفون if any linear question comes, how to solve in any case, okay? But that's a good question that is given in the mock test to explain all the concepts together. So if you have any questions about 1 and 2, feel free to ask now before we start for the friction questions. If anyone's still here, please just give me a thumbs up reaction or just type you understand in chat or everything's clear. So I know that everyone is at least listening to me. يعني ما قاعد أكلم نفسي بس. All right, perfect. Excellent. It's okay if you need to review. This session is going to be recorded. Inshallah, as soon as I'm done with the session, I will be uploading it to the YouTube, and with the remaining of the videos that I have uploaded, I'm going to be sharing the entire playlist. I'll send you an email about it as well, Ashan. If you weren't in the chat or if you cannot access this chat for any reason, you're going to have all the notes, and all the notes that I'm writing down here, I'm going to share with you guys as well through email. All right, I'm going to send it here and through email, inshallah. Tamam. Let's start with the friction question. All right. A 4-meter ladder weighing 200 newtons is placed against a vertical wall as shown in figure 3. Okay. As a man weighing 800 newtons reaches at point 2.7 meters from A, so this is point A, a man reaches 2.7 meters and his weight is 800 newtons. The weight of the ladder is 200 and it's going to be in the middle of the ladder. All right. The ladder is about to slip. When you read the ladder is about to slip, this means that this is all in equilibrium, and I'll explain what that means in a bit. Assuming that the coefficient of friction between the ladder and the wall, so there is friction here, this isn't a smooth wall, so we have a mu value between the wall and the ladder, which is 0.2. Determine the coefficient of friction between the ladder and the floor. So we need to find the mu at point A, which is between the floor, the ground يعني, and the ladder itself. Also draw the free body diagram of the ladder showing clearly all the forces and their directions. Even if this wasn't a part of the question, you will always draw the free body diagram to be able to analyze any ladder question. All right, so the first step will be is to draw this free body diagram completely from scratch in your own way. فأول شيء, we have our floor over here. Okay, and we have our wall over here. Okay. This is point A at the bottom. We have our ladder. Let's draw the ladder. So the ladder is something like this. Over here. Let's see what we are given. We are given that this is 60 degrees. We are given that this force over here at the center is the weight of the ladder, which is 200 newtons, and a point up here, right? Obviously, these dimensions are not to scale, 800 newtons. And we know that this is, I'm not going to draw it on this because we don't need to mention the distances. Later, we're going to look at it each one separately. But the distance for the 200 newtons is given to be 2 meters from point A. This is point A over here. And this is point B. All right. So for point A, I'm going to do all my forces at point A. Actually, yeah. So just keep it as point A, point B for now. Point A and point B. So we drew everything that we have from the question, except the distances. The distances we'll look at after. So we don't need to look at this figure anymore. We can analyze using the free body that we have used. So we'll just leave this here. And we're going to use all the information that we have from this. So now we need to determine the forces. So if this ladder is slipping, Okay, if this ladder is slipping معناته if this ladder slips, it's going to slip in this way, and it's going to fall in that way. So معناته this is going to fall downwards and this is going to fall to the left. All right. Remember that friction is the opposite to motion. So if it's falling down this way, this will be the direction of our friction. So our friction at B, I will call this FB, is in that direction upwards. Why? Again, this is a very important point because you need to make sure your directions are correct. If there is slip, معناته the direction of slip is going to go slip downwards. يعني إذا حاطين لادر على طوفة إذا تزحلق بيتزحلق على تحت. For the motion is going downwards at point B. For the friction is opposing that motion. Same thing with A. If it's slipping, this ladder is going to slip to the left. إنزين فمعناته our friction force is going to be towards the right. So this is going to be my friction force FA. إنزين so this is how you determine the direction of your friction for both cases. What about the direction for our normal? Our normal is always perpendicular to the surface, so it is going to be upwards from here. And then it's going to be upwards from here, going up like this. This is our normal force A. NA as in the normal force at point A. And then we have a normal force over here. Again, it is going to be perpendicular to the surface, opposite to the surface, which is NB. All right. So normal force is basically where the surface is perpendicular to it in both cases. And always your friction and normal will have a 90-degree angle between them, which is logical, right? Very first step I always do is I determine my positive and negative direction. So my positive and negative direction. So this is going to be my plus y. So anything upwards is plus, and anything to the right is x. You can choose it in any way. You can choose down to be positive. You can choose left to be positive. It's fine. But select a specific dimension, يعني a specific coordinates, a specific direction, and follow that for all the rules that you're going to apply. Okay? One last thing that I didn't mention. It was given in the question that the coefficient between the ladder and the wall here, mu, is equal to 0.2. Right? This was given in the question. So mu of B is equal to 0.2. And what are we trying to find? We're trying to find mu at point A. Okay, so this mu A is what we are trying to find for this question. So once I have drawn my full free body diagram, now I can start actually solving the question. Do not wait, do not start solving anything, do not write any equations لين ما تحللون السؤال بالكامل and you draw the full free body diagram, then start with the equations. All right, so the first equation, so the first step now here, we're done with this, with the free body diagram. Okay, so first step is free body diagram. All right, that is our very first step. And then the second step would be our equations. So the first equation we will do, the second step is our friction equations. And then that would be your second step. You will find your friction equations. What is that? Remember that friction, and then friction, يعني this is friction is equal to mu times n. This is what this means. You're going to use this equation for your analysis. So the first friction we have is at point A. So F of A, friction at A, is equal to mu of A, which we are trying to find, times NA. Okay, this is our very first equation. So this is equation 1. I like numbering my equations عشان أعرف equations اللي بعدين. I will substitute everything. I know which equations I have to use. All right. So this is the first friction equation. The second one is for the wall. So the second one is going to be FB is equal to mu B times NB. And we are given mu B. So I'm just going to substitute that value. FB is equal to mu B times NB. Mu B is given to be 0.2 NB. All right, and this is my second equation. Tamam? So this is your second step. Your second step would be finding the equations due to the friction equations that you can find. Your third step will be your sigma F equations. All right? Or a better way to write this is the summation of forces equation. So summation equations, which are sigma fx equals 0 and sigma fy equals 0. Okay, this will be your third step. All right, so let's start with sigma fy. And then I'm gonna just copy paste this down so we can see it a bit more clearly. When we do our sigma fy, all right, so that was our first step. 1 second. We finished step 1 and step 2 and we have determined our equations. So let us now do step 3 and determine our sigma f equations. Okay, so we have sigma fy first. Let's do that. Sigma fy is equal to 0. Sigma fy معناته شنو? Sigma fy is all the forces in the y direction. Anything going up is going to be positive because that's how I determined my positive direction. So NA is going upwards. FB is also going upwards, so plus FB minus 200 newtons, because 200 newtons is going downwards, minus 800 newtons. And this has to be equal to 0 because it's equilibrium. Remember when I said it said about to slip over here? That basically means that your sigma fx equals 0 and your sigma fy equals 0, meaning you're in an equilibrium case where there is no motion. معناته the sigma of fy should be equal to 0 and the sigma of fx is equal to 0. If I rearrange this equation, then I am going to get that NA, and this is just a simplification of this equation up there, plus FB يساوي, I take everything else to the other side, 200 plus 800, which is 1,000 newtons. All right. So this is our equation 3. Tamam? So we have equation 1 and 2 from the friction equations. Now we have equation 3 from the summation of equations of Fy. Let's do the same thing again for Fx. So sigma Fx equals 0. Sigma Fx are the forces on the x direction. What do we have? We have Fa going to the right, so it's positive Fa. And then we have the only other force is Nb, which is going to the left, so it's minus Nb. And this is going to be equal to 0. Therefore, if we just rearrange this equation, we're going to get Fa is equal to Nb, right? Equal to Nb. And this is our fourth equation. This, we use the summation of equations, all right? So sigma fx equal y, summation of forces, I should say. Summation forces equations, all right? So now that we have determined all of these, notice that we have how many unknowns? We have 1, 2, 3. So each color is an unknown, 4, and 5 unknowns, but we only have 4 equations. That's why we need to use a fifth equation, which we will be using, which is the summation of moment. So our fourth step is summation of moment about a point, let's call it A for now, equal 0. And I'll tell you why I chose A in a bit, okay? And again, we need to assume a positive direction. So we're going to assume clockwise is positive, okay? This is an assumption. You can choose whichever assumption you want, left or right, or up and down, clockwise, anti-clockwise, up to you. But stick with your assumption and solve accordingly. So if we look at this again, just let me copy paste it down there. So we have this, okay? I'll make it a bit smaller because we don't need all this size. We just need to look at it from a specific point. If we look, we don't need to look at mu b. We just need to look at the forces now. We don't care about mu. We just need to look at the forces. I'll make it slightly bigger. So this is what it looks like. And then the way you should do this analysis is, first thing, you're going to write your equation. Then just write your equation as a whole. So equation of moment about A is going to be equal to, all right? So why did I choose point A, first of all? If you notice at the very beginning in the question itself, in this figure, then they gave us the distances from A. Therefore, it is easy to determine the perpendicular distance for each one using this A, because that is where they used as a starting point. That is why I chose A. If you choose B, again, completely correct, nothing wrong. You can solve your equations. But the reason I chose A is because the distances have been given from point A, and it will simplify, and you will see how now. Okay, so we don't need to look at this anymore. We go back to here. Then, so when we are taking the moment about point A, all right, the forces that are going through A are going to be cancelled out. They're not going to have any moment effect. So NA and FA are not going to be a part of the equation. We don't need them. The 200 Newton force is going to be causing a moment. So we know it is going to be 200 Newtons. All right. This 200 Newton force, I'm going to need as much space. So I'm going to put it this way. This 200 Newton force, the direction of it, if we look, going to point A is in this direction. So it's going in a positive direction. Therefore, this is going to be plus 200 times the perpendicular distance of the 200 that we need to find. All right. The perpendicular distance is basically going to be this distance from here to here. This is our perpendicular distance, this x over here. I'm going to call this x200. Ashan, we know that this is the 200 force, and I'm going to highlight it. Ashan, we know that this is one variable. All right. So this is our x200. This is our perpendicular force that we are trying to find. Okay. Actually, I'll change the highlight color to green for now. لأن بعدين it will get confusing. So I'm just going to keep it as green. Okay. This is the perpendicular distance for the 200 Newton force. So we're done with the first force. Let's go to the next one. 800 Newton force. So we know that it's going to be force times distance. Remember that moment simply equal to force times the perpendicular distance. All right. This is all I am doing right now. Force times perpendicular distance. Again, let us look at the direction of the 800 Newton force. It is going into this way. So it is forming this side, which is again a clockwise. So it is positive. This is in the clockwise direction. And then clockwise, so it is positive. معناته we're going to do plus 800. Again, we need to find the perpendicular distance. The perpendicular distance for this 800 is, if I draw a line here to point A, this is my perpendicular distance, and I'll call this x 800, okay? This distance over here to here. This distance is just going to be x 800. So I'll call this x 800. Okay? And I'm going to highlight this in purple. We are done with these two given known forces. Let's look at our unknown forces. Okay, so we have FB. FB, let's look at the direction of FB. FB is going this way. So it is going into this motion. This is counterclockwise or anti-clockwise. So it's negative. So we know that this is going to be minus FB, which is our force, times the perpendicular distance. Where's the perpendicular distance for FB? FB, the perpendicular distance is going to be, oops, this distance over here. If we extend this force, this is our perpendicular distance, and I'm just going to call it x and have it in red. All right. So this total distance is going to be x. From here all the way till here, this is going to be our x. Okay. Distance-wise, this is going to be our x. And now let's look at our final thing, which is NB, the final force that is having a moment. First, let's look at its direction. So if we point this to A, again, it is going into this way, and this is anti, so it is negative. All right. So this is going to be minus NB. And where's the perpendicular distance for NB? Perpendicular distance for NB is this distance over here. ليش؟ لأن if you extend the force to point A, this is point A, all right? This is our perpendicular distance. The highlighted part, this highlighted part, this is the perpendicular distance, all right? So this is equal to this distance over here. And we will call this distance y, all right? So the distance from here to here, this is our y distance, okay? So now we have our equation, but what are we missing? We are missing all our perpendicular distances. No worries, we're going to analyze each perpendicular distance by itself عشان ما يكون فيه خربطة. Let us start with the 200 Newton force. So for the 200 Newton force, it is going to be a triangle. So if I draw the triangle, it's going to look like this. Then this is our triangle, all right? This is basically, if I'm drawing this triangle over here, يعني من هني لين هني. Okay, this is my triangle. This is the triangle I am drawing, because we remember, what is the x we need? This is our perpendicular x. x200 is over here. This line over here. So this over here, the highlighted green part, this is our x200. Okay, this is x200, right? So again, let me just make some space because I don't want to scroll more. So we have a right triangle over here. Let's see what we are given. We know that this is 60 degrees. Okay, and this distance was given. This distance over here, the distance هذا, it was given to us in the question to be 2 meters. All right, so we know that this is 2 meters. Okay, again, you can use SOHCAHTOA, you can use any method you want, you can use the shortcut method you've learned. Since x is adjacent, this is the hypotenuse, so x200 is equal to the force 2, or hypotenuse in this case, and then 2 cosine, because it's the adjacent one, 60. All right, again, if you want, you can use SOHCAHTOA if you want, and you will reach to the exact same point, but I'm just using the shortcut so that I can have everything close to each other. All right, so x200 is equal to 2 meters times cosine of 60 degrees. Okay, يعني if we calculate this, x200 is going to be equal to 1 meter. So our x200 is going to be 1 meter. So we have found our x200. Now we're going to do the exact same thing again for the 800 Newton force. All right, let me actually make this a bit lower to there. Okay, so now we're going to do the same thing again for our 800 Newton force. Okay, so again, we're going to draw the triangle. It's going to be a very similar triangle to the one we had before. Again, this triangle is simply just the 800 Newton force, this triangle over here, لأن we're trying to find this distance, which is x800, all right? We're trying to find the perpendicular distance over here. This is our perpendicular distance again. Remember that this is a right angle. Again, this is 60 degrees, all right? And now we were given in the question, في الدايجرام هني, this is 2.7 meters from point A. So this is going to be 2.7 meters. This is why I chose point A, because now it makes it so much simpler to do my triangles one by one. All right, so this is x800. Again, x800 is equal to 2.7 cosine 60. This is the shortcut. If you want to use SOHCAHTOA, you can. So x800 is equal to 1.35 meters. All right, again, x800. This is our x800, all right? So we have found now our second perpendicular distance. Now we need to just look at the big triangle as a whole. All right, this is the big triangle. This is for everything, يعني FB and for NB. This is our Y. And this is our X. This is X. This is Y. Okay, so Again, this angle is 60. And we know that given in the question, this total distance is 40 meters. This is just now the big triangle, the full triangle, okay? This full triangle, now we are doing the analysis for it. We need to find y and we need to find x. So we're going to have to use two equations. So x, again, is adjacent. So x is going to be equal to 4 cosine 60 degrees. X is equal to 2 meters. And y, it is opposite, so it is sine. Y is opposite, so it's 4 sine 60 degrees. Y is equal to 3.464 meters. Again, you can apply SOHCAHTOA and analyze these triangles. You guys should be already very familiar with this at this point in your studies. That's how I just basically used the shortcuts and applied. And now I have gotten every single perpendicular distance I need for this equation. I've already determined the directions, and I know that this is going to all be equal to 0 because sigma moments is equal to 0. All right? This is equal to 0. Tamam? Just 1 second. Sorry about that. Okay. So MA, we have found the equation. We have found all our perpendicular distances. Let's substitute all our perpendicular distances now. Okay, x and y. We found this to be 1 meter, x 200. This is 1 meter. Okay, x, actually, 1 second. Let me put both equations above each other. عشان you guys can see what will happen. So if I bring this down here. Okay. So x200, we're going to substitute the value for x200 هني, which is 1 meter. All right. And for x equal 800, we're going to substitute the value we found for x 800 over here, which is 1.35. For x, again, we will just substitute the value we have found for x, which is 2 meters. All right. And for y, we're going to do the same. We're going to substitute the value for y, which is 3.464. 3.464. All right. Let me clean this up a bit. So 3.464 meters. And this is all going to be equal to 0. If we simplify this equation, all right, we are going to get just 2FB. All right, so I'm basically taking FB and then B to the other side. And this is how we're going to get the equation. So 2FB minus, plus 3.464 NB, and then is equal to 200 times 1, which is 200, plus 800 times 1.35 is going to give us a total of 1280 as a value, and this is our equation 5. Tamam? So again, just a very quick recap. We have from the very beginning of the question. First thing, you draw your free body diagram. Second, you find your friction equations. You're going to get 2 equations, one for the wall and one for the ground. Third, you're going to get 2 equations for your sigma Fy and sigma Fx, so 3 and 4. And then you're going to use your moment equation at a specific point, either A or B, depending on which one is easier for you. وبعدين you will find your 5th equation here. So let us group up all these equations now. So we have, let me copy paste these down here. We don't need this part. So this is equation 1 and equation 2. And equation 3 was over here. This is equation 3. Okay. To make it a bit smaller, this is equation 3. Equation 4 was over here. عشان I number my equations so I can easily spot them when I want to simplify everything. This is equation 4. And finally, this is equation 5. Okay. So these are all the equations that we have come up with. Okay. Equations 1 to 5. Now, notice one thing here. عادة you guys are going to be substituting and canceling, like in previous examples. If you've seen the previous questions from the worksheet, you will be directly like substituting each one in the other and all of that. The method I always do is I try to get rid of the friction forces. In those cases, I try to get rid of friction forces and find everything in terms of NA and NB. And then that's what I usually do. In this case, however, notice one thing. Notice that equation 2 and equation 5 are simultaneous equations that you can solve with two unknowns and two equations only. يعني هني FB is equal to 0.2 NB, and here FB and NB, these are your only two variables. So you can find these values and then just plug in to make your life so much easier in a question like this, okay? So the way you will do this is 2 and 5 then are simultaneous. So we're going to use that equation. Let me just keep this on the side here, like that. And this, we're going to solve for this. So 2 and 5, we're going to just substitute FB, the value of it, which is 0.2 NB, in here. So it's going to be 2 into FB. Okay, I'm going to just put red brackets so you know that this is a substitution for FB, is equal to 0.2 NB. All right? Plus 3.464 NB is equal to 1280. That's it. And now you can solve for NB directly. And once you find NB, you can solve for FB because you have two equations, two unknowns. So if I simplify this, 2 times 0.2 is 0.4 NB plus 3.464 NB is equal to 1280. All right. 0.4 plus 3.464 is going to be it's going to be 3.864 NB is equal to 1280. Divide both sides and you'll find that NB is equal to 331.263 newtons. So we found our value for NB directly. How did we do this? We substituted equation 2. All right. So what we did here is 2 into 5 by substitution. Right? So we substituted equation 2 into equation 5 to solve. Now that we found NB, we can also find FB because we know that in equation 2, if we look at equation 2 now, equation 2, FB is equal to 0.2 times NB. And NB is 331.263 newtons. So FB is equal to 0.2 times this is going to give us 66.253 newtons. We found this equation now, right? We found these two, variables, NB and FB, and now we can substitute in order for everything else. So equation 1, we cannot still because we haven't found NA or FA, but let's go to the next one, equation 3. So equation 3, all right, is NA plus FB is equal to 1000. So NA plus FB, we have already found the value for it. So we're just going to put in the value, which is 66.253 is equal to 1000. So you can solve for NA by taking that to the other side. NA is going to be equal to 933.747 newtons. All right. So now we have found NA. Now we just need to find the last unknown, which is friction at A. So let's go look at equation 4. Equation 4 simply says FA is equal to NB. So if equation 4 says that FA is equal to NB, and NB we have already found from the very beginning. It is 331.263. NB is the first one we found here. All right. So simply FA is just equal to that value. FA is 331.263 newtons. What was the question wanting us to find? Mu A. That was what the question wanted us to find from the beginning, remember? So now we can bring equation 1 here, okay? And we can substitute the values for FA and mu, and NA. So FA is 331. So FA is 331.263 is equal to mu A, which we are trying to find, times NA, which we have already found earlier as well. NA is 933.747. 933.747. Therefore, mu A is going to be equal to, you just divide these over each other, and you're going to get your value of 0.355. Okay? That's the whole idea of a friction force. Sorry, a friction question, a ladder question. You just simply, you can plug in everything back in. In the case when you have too many unknowns, refer to my previous videos. I solved all the questions for ladder except question 5, but question 5 is similar to the solving of this one. But for the ones with too many unknowns, again, you're going to reach an equation at the very end after substituting everything, where one of the variables will just cancel out with each other, and you'll be remaining with another one. And you can refer to the previous explanation of each one. I went through those clearly. But again, quick recap, you're going to have 4 major steps. Your first step is the most important, drawing a proper free body diagram. لأن لو ما رسمته هاي صح، هذا الفري body ما رسمته صح، كل شيء بعدين الحل بيكون غلط. فdraw your free body diagram. خلصتوا من free body, get your friction equations. FR اللي هو FA و FB. You're going to have 2, one for the wall and one for the ground. In the case في السؤال قالوا a smooth surface, just know that means your mu is equal to 0. يعني your friction force is equal to 0. All right? So a smooth surface basically eliminates one of these equations, but it also eliminates an unknown. Then it only eliminates your friction force, huh? It doesn't eliminate the normal force. The normal force is still going to be there, but there's going to be no friction on a smooth surface. So that's your second part. So your third step, your sigma Fy and sigma Fx equations. Make sure when you're drawing a free body diagram, you determine your positive directions. Once you do, you're going to just apply sigma Fy equals 0 and sigma Fx equals 0. Whatever equation you get with your pluses and minus, arrange it in a way that your variables are on the left side and your non-variables on the right. Usually, and here I wrote it as NA plus FB equal 1000. نصيحتي خلوا FB by itself on the left, and it will make your substitution later on much easier. All right, but it's the same thing. You can either do the step here or later on. It's the same thing. After finishing with this, we're going to go into our moments. Moments, again, assume it's positive direction. It is preferred to assume clockwise to make it easier. Once you assume it, write your equation, okay? So you know, first of all, your directions, whether they're positive or negative, and you need to identify where your perpendicular forces are to each moment, all right? So again, the perpendicular force is just, you're going to extend the force, and then the distance that is going to be from A to that, يعني. For this 200, just as an example, you're going to be extending the force for the 200, and you're going to be drawing the distance from here to that 200. That is your perpendicular distance x, 200. Okay. Again, I will repeat. Let's say for the 800 Newton force, you're going to draw a straight line, and then it's the distance from the point you're taking the moment. This is your distance over here. All right. And that is the perpendicular distance. You guys should be familiar with this now. So you need to determine each perpendicular distance using trigonometry. Again, you're going to draw the triangles of each, locate where your perpendicular distance and make sure you know which side it is. Using SOHCAHTOA, you can solve for each triangle, and you'll be able to find all your perpendicular distances. Plug them back into the equation. You will be coming back with your fifth equation. Once you're done with the fifth equation, now you have your 5 equations for 5 unknowns. Start solving immediately by substituting for FA and FB if there is too many unknowns. In this case, we already had 2 equations with 2 unknowns, so it will simplify all our work. Therefore, we decided to just keep it the way it is and solve for 2 and 5 first by substitution, so we can get an actual number to plug in, and it will make the rest of the substitution easily. Then go in order. Number 1, we cannot do anything, so we look at number 2, we can find FB. We look at number 3, since we found FB, we can find an A. We look at number 4, we have NB, we can find FA. Then we look back again at number 1, and we have FA and NA to find mu A. تمام؟ ما شاء الله ساعة تقريبا عشان نحل هالسؤال. So now you guys can ask your questions about point A. We don't have, so we use SOHCAHTOA for Y, A basically. Any questions about the friction? I know يعني there's a lot of information. ساعة قاعد أتكلم، ساعة قاعد أحل سؤال. A lot of things might be confusing. The best way, practice the question yourself when you're solving. Without looking at my solution, just look at the steps. Remember these steps, and then you'll be fine. Step 1, free body. Step 2, friction. Step 3, summation of forces. And step 4, summation of moments. وبعدين everything are just concepts you have already learned from before. يعني ما في شيء جديد. Okay? بعدين in the substitution, go step by step again. Step by step, and refer to my old video when it comes to too many unknowns. And there I show a very clean way of doing substitution. Okay. Why do we use moments in general? Again, the reason we are using moments لأن لو تشوفون هني we have 1 unknown, 2 unknown, 3 unknown, 4 unknown, and 5 unknown. We have 5 unknowns, يعني 5 variables that we need to determine. You need to have the number of, if you remember simultaneous equations, if you have 2 unknowns, you need 2 equations to solve. If you have 3 unknowns, you need 3 equations to solve. هني عندنا 5 unknowns, so we need 5 equations to solve. So this is equation 1, equation 2, and then summation of forces are going to give us equation 3 and 4. But we need one more equation from moment, okay? That is why we only do moment about A. If we had 6 unknowns for any reason, we're going to also do the moment about B to get a 6th equation. That is the whole concept. That is the whole idea. But since we only have 5 unknowns, we need to form 5 equations. Once we form our 5 equations, we can do our substitutions directly. تمام? We'll take another 5-minute break لأن كان سؤال ثقيل حتى صوتي شوي راح. عادي, don't worry. I know I said until 6, but I will finish the last question before we complete the session. And then think of your questions right now. If you have any questions about friction, I'll answer them. All right. I just need to make a phone call as well. So we'll be back in 5 minutes exactly. So at 5:50. All right. 55, sorry. We will be back. Think of any questions, write them in chat. When I'm back, I will just start answering them. And then we will solve the last linear equation, linear question, I mean, and we will be done, inshallah. Tamam? So do you guys have any questions about the friction problem? عارف اكثر شيء غرق هو الفريكشن بروبلم، بس if you follow these steps اموركم طيبه. حق any friction problem they give you follow these exact steps and you will always be able to solve any friction problem. حتى لو عندكم مشاكل في substitution at the end, that's fine. You will get most of the mark for doing all the steps that you have done. And substitution, if you follow what I did in this video and in my previous videos, bad, you will not have any problem with it. But once you follow all these steps, for any friction problem, you can solve it this way. إن شاء الله معطيكم بس ميو. زين معطيكم مثلا بس mu of the wall, solve for everything else. Now you know how to solve for everything else. Okay. Most of the time, if not all the time, بيكون عندكم 5 unknowns and you need to form 5 equations. The first one friction, second one يعني أول شيء ترسمون الفري بودي طبعا. أول شيء بتسوون friction بيعطيكم 2 equations، بعدين بتسوون السيجما اف اكس سيجما اف واي بعد 2 more equations، وبعدين بيعطيكم المومنت، يعني بتحصلون المومنت equation and you have to determine directions and all of that وبعدين you solve for all of it. تمام. Okay, let us look at linear motion. The linear motion question says an object accelerates uniformly from rest to this speed in 10 seconds, after which the speed remains constant. Then the object decelerates at this speed in 10 seconds, after it accelerates again, and then the object accelerates further. فتعرفون ان عندكم object, it is accelerating, and linear motion means it's in a straight line. We have a straight line. زين. Linear motion معناتها straight line. Okay, so we start from this point. Let's start from the first point. I will mark it as purple. This is our point 0. زين. So here we are going to read the very beginning. So it accelerates uniformly from rest. Rest معناتها شنو؟ معناتها v at this point, we'll call it v1 equal 0. زين. And t1 time 1 بدينا from time which is equal to 0. بدينا من 0 seconds. But v1 is kilometers per hour. t1 is 0 seconds. Okay. شو صار؟ دقيقة بس. زين. t1 is 0 seconds and x over here, this distance we will talk about it in a bit, is also it's starting from x1 which is 0. يعني x1 هني is 0. Okay. x1 equal 0. 0 kilometers مثلا. زين. So this is our starting point. This is how you should always start. You're going to have an initial velocity, an initial time, and an initial x. Always do it in this way, and I'll explain why in a bit. It goes up to 540 kilometers. يعني قطع مسافة الحين. زين. ووصلنا to a second point. A second point over here. زين. At this point, our velocity now, velocity 2, is equal to 540 kilometers per hour. زين. Let me make this a bit smaller so I can write these a bit bigger. زين. Okay. So we started from rest, then to a speed of 540 kilometers per hour. And how much time was taken? Time 2 is equal to 10 seconds. زين. خذلنا من هني لين هني 10 ثواني عشان نوصل هالنقطة. زين. So this is a time of 10 seconds. And we have covered this distance. Okay, we have covered this distance. I will do it in red. And then we have covered this distance. this distance over here. This distance covered, okay, it will have a specific acceleration. لأن عشان velocity يستوي أكثر لازم تدوسون، يعني مثلا نقول سيارة، let's take a car because it's the easiest example. إذا أنتم واقفين إذا ما دستوا السيارة ما بتتحرك، لازم تدوسون، you have to accelerate عشان you reach a specific velocity. So we're going to call this acceleration A12, as in the acceleration going from point 1 to point 2. And here we have covered this distance, which is distance x12. Okay, this is how I usually do the analysis to make it much simpler. To cover a specific distance, you need to have a specific velocity, and to have an acceleration, you have to have a change in the velocity. لازم قاعدين يا تسرعون يا تقللون سرعة اللي هو بس الvelocity بيتغير كذي. So we have here our second x12. All right. This distance, this red distance, is x12. And we have a specific acceleration to go to this point. So we are done with this part. After which, the speed remains constant. Okay? Here it says speed is constant for 10 seconds. يعني, for another 10 seconds, let's go to this point over here. Okay? We have covered this distance now. Okay? The distance, this is 0.3, so V3. Let me move this a bit to the left. So V3 here, it did not change. It said speed remained constant. But V3 is also 540 kilometers per hour. Okay. Time 2. Now, the time here, we are going to look at the total time. يعني from time 0 لين ما وصلنا هني كم ثانية كملنا؟ بعد 10 ثواني فصاروا 20 ثانية, 20 seconds in total. Meaning, this is the time from the very beginning. We are looking at this point, at this specific point من time 0. يعني مثلا لو انتم الحين قاعدين تسوقون السيارة من طلعتوا من البيت يوم بطلون تايمر زين قاعدين تسرعون ل 540 كيلومتر هاي أول 10 ثواني بس التايم is still ticking لما توصلون لهال value. You have continued this extra distance. It took you 20 seconds totally from 0. Okay. So T2 is equal to 20 seconds. And again, the same thing. هني لازم يكون عندنا distance covered اللي هو x12. Sorry, x23 from 2 to 3 يعني. Okay. Which is gonna have an acceleration from 2 3, but because it is constant, you can instantly know that there's no acceleration لأنه ما تغير السرعة. And remember, we're dealing with average acceleration. So ما قاعد يتغير السرعة. طالما يعني انت مثبت السرعه انت ما قاعد تدوس ريس يوم تثبتون السرعه في السياره ما قاعد تدوس ريس فما قاعد يعني you're not accelerating anymore, you're not having any extra acceleration or any more velocity changes. This means acceleration 2-3 is 0 meters per second squared, and I'll show you again how, or meters, yeah, kilometers per hour squared or whatever. I will talk about units in a bit. But this basically means that it is a constant velocity فما عندنا acceleration, so kilometer per hour squared. So this is at point 3, and the distance covered is x23 from this point, from the red point to the green point. So let's continue reading الحين. So the object then decelerates to a speed of 360 kilometers per hour in 10 seconds. يعني الحين بطأ السرعة. فمن هني لين هني another distance مثلا. Okay. This is our point 4 now. فالحين V4, what is the velocity we have at point 4? It is 360 kilometers per hour. Okay. And T4, this is T3. Sorry. Okay. T4. الحين احنا من البداية كم كملنا؟ It was another 10 seconds. يعني in this orange part it was an extra 10 seconds. So 20 plus 10, which is 30 seconds الحين وصلنا. All right. So we have reached at this point. لأن we assumed at the beginning, when we didn't assume, it said it starts from rest, and time when we start from 0, we start time always from 0 seconds unless it's given in the question. And the distance covered at the very beginning, يعني we started from point 0 اللي هو بس x1. Okay. So now we reached V4, and now again we have the same idea. We have a distance covered here, which is x34, and an acceleration a34. All right. Then it accelerates again. So it accelerates again to 1080 kilometers per hour. فبعد مرة الحين بعد it's accelerating. I'm just making the size larger. It doesn't mean the acceleration is more or less. This is just عشان I can write easily here. So V5 is equal to كم وصلنا السرعة 1080 kilometers per hour. Right? T5 الحين, how many seconds did it take? Another extra 10 seconds. ف 30 plus 10, 40 seconds الحين. من البداية we completed 40 seconds of time. Again, we're going to have a new distance of x45 and an acceleration of a equal to a45. And we will calculate that later. And finally, at the end, the object accelerates further from 1080 kilometers per hour to 1440. يعني من 1080 وصلنا ل V5, which is the end of the line here. V5 or V6 وصلنا, which is 1440 kilometers per hour. And here the time, again, in 10 seconds. It mentioned in 10 seconds. So 40 plus 10, 50. What does this mean? The time, if I'm looking at the time, يعني it took 50 seconds for this entire trip. إنزين? This is what is meant. And I would recommend you always write it in this way. افهموا يعني من وين لوين. لأن بعدين when you want to do calculations, it will make your life so much easier. إنزين? In this case, it's easy because everything is 10, 10, 10 seconds. It will get complicated if it's 10, 15, 35. But if you follow these steps, it will always be simplified at the end. Again, we covered the distance of x 5, 6 and an acceleration of a 5, 6. All right. So this is what I would recommend my first step is. Determine your initial and final velocities for each sector. Okay. Your initial velocity here is V1, يعني the red sector. Initial velocity is V1, final velocity is V2. لأن هني في purple is where we started and red is where we ended. So purple is V1, which is 0, and red is V2, which is 540. For the green part, we started from red. So our initial now is red for the green part, and the final is V3, which is green. Same thing for the rest. After you have completed this step, whatever type of question is given, after you have completed the step, very important to convert units from kilometer per hour to meters per second. And then this is a very, very important step to do. You have to do this conversion. It is very important. If you want an easy way to do it, when you're going this way, you're going to be dividing by 3.6. And then I will explain how I got this 3.6. And if you're going the opposite way, we're going to be multiplying by 3.6. And then again, conversion of units is very simple. Let us take V2 as an example. And then just as an example, V2 is equal to 540 kilometers per hour. And then فإحنا نبغى in meters per second. So we have to multiply by meters up, kilometers down. Meters is 1 kilometer has 1,000 meters in it. Okay. Times بعد we need to convert the hours into seconds. So how do we convert hours? We have to multiply by hours and divide by seconds. عشان يتكنسلون. The idea here is so that we could just cancel now kilometer and kilometer, and hours will cancel, and we'll be remaining with meters and seconds. So 1 hour has 3,600 seconds in it, or 60 minutes times 60 seconds. And then 3,600 seconds in it. So if you notice, if I simplify this equation, it is 540 times 1,000 over 3,600, or it is equal to 540 divided by 3.6. Okay, if you do the simplification. That's why, and this is going to give us 100 meters per second. تمام? This is, or 150, sorry, 150 meters per second. تمام? فمن ناحية الconversion, if you want a quick, easy way of converting, divide to go to meters per second, multiply to go to kilometers per hour. Then kilometers is large, so you have to multiply to reach kilometers. Meters is small, so you have to divide by to reach meters. This is how I usually memorize it, عشان I do it quickly. Okay? We are going to do this simple trick for everything now. So I'm going to just redraw this, and I'm going to change the entire units all over again. That is all I'm going to do. Okay? So it's the exact same thing, that nothing has changed. The only difference is now we are not going to be dealing with kilometers per hour. We are going to be dealing with meters per second. يعني everything that's kilometer or hour, we're going to change to meters and seconds. Okay? This whole value is going to change. This whole value is going to change. Okay? So 0 is just going to be 0. So this is going to be 0 meters per second, 0 kilometers, 0 meters. V2, and then if we divide by 3.6, we get 150 meters per second. V3, when we divide by 1.6, remember this was constant, so it's also going to be 150 meters per second. And then all I'm doing is just the conversion of units. I showed it for one example, but I'm applying it for all of them. So V4 is 100 meters per second. This is 0 meters per second squared الحين acceleration. V5, which was in blue, V5 is 300 meters per second. V6 is 400 meters per second. Okay, this is the first step you'll do. You are going to do your conversion. All right. So let us now actually start answering the question and see what is they're trying to they want us to find. And then the first part of it, at least. The first part only says plot the speed versus time graph. And then, so when they say speed versus time, when they say plot anything, the first value is going to be your y value. The second value is going to be your x value. So it's always y versus x. And then, so let us do that now. Let me just draw it here and try to be as accurate as I can. Okay. So I'm gonna say that this is time. Actually, let's make it bigger. Let's say this is time at 10. So 2, 4, 6, 2, 4, 6, any, 2, 4, 6, any, 2, 4, 6, any, but 10, 20, 30, 40, 2, 4, 6, 50. All right. If I draw these lines, let me make it a bit thinner. So these are my timelines, يعني at these specific times, because remember, let me just finish these and I'll show you. So these are our times from 0 all the way up to 50 seconds, because that's the trip duration. Okay. Second. انزين. هني عندنا velocity. This is velocity in meters per second. This is our velocity, and this is our time in seconds. Okay. So this is our 10 seconds. This is 0, 10, 20, 30, 40, and 50 seconds. Okay. And then let's do 100. So this is, let's do this as 100. 1 to 200. 1 to 300. And 1 to 400. Okay, let's do it this way. Then our largest velocity is 400 and our smallest velocity is 0. Okay, now we can start drawing from 0 to 10. Let's look at what's happening from 0 to 10. So from 0 to 10 seconds, it's this red line. So velocity starts from 0. Okay, so it starts from 0. تمام. But it's accelerating up to 150. بيوصل ل 150, which is over here. So this is our first line. From 0 to 10 seconds, it's going from 0 meters per second, this is 0, to 150, which is over here. Okay, this is 150. And then, again, same thing will be done for each part. So from 10 to 20, velocity did not change. It's 150 and 150. If you notice, velocity is going to stay the same. It's 150. It starts from red at 150, and at green, it's also 150. Now, from green to orange, yani from the 20 seconds to the 30 seconds, عندنا 150, it's going down to 100. So the orange part, it is going down to 100. So it's going to be something like this. Okay, from here to here. Okay, it's going down to 100. But then again, from 30 to 40, V5 is 300. So now the blue part is going back up to 300. From 100 all the way to 300, which is over here. Okay. And then the last one is going from 300 to 400, which is the brown part. So 400 is over here. And this is what it will look like. This is your basically your speed versus, or your velocity versus time graph. Okay. This is how you will draw it. So you're going to look at your initial, next, all the way to the end and equate their values. So keep in mind, this is A12. This is the acceleration here of A23. If you notice, the slope here is 0, which I will talk about a bit. That's why A23 is equal to 0. And then here we have A34. This is A35. And this is A3. Sorry, what A35? A45. And this is A56. Okay. Move these up. So let me explain the concept through a graph. So when you have a velocity times time graph, the slope is going to be equal to your acceleration. So let me just make these a bit smaller because we don't need these large lines over here. Insane. So the slope is going to be your acceleration. This is how you can determine it very easily if you draw the graph. Okay, slope is equal to acceleration. Okay, and area under the graph, is going to be equal to your distance that is covered. So when you have a velocity times time graph, you can always directly find the acceleration through the slope. يعني, for example, how do you find slope? It's rise over run. y2 minus y1 over x2 minus x1 لو تتذكرون. فبيكون 150 minus 0 over 10 minus 0. زين? And that's how you'll find your first acceleration. Okay? And for area, you're just going to find the area under these, يعني the shaded area under these parts. So it's going to be this entire area over here. The area under all of this to the x, this is going to be your displacement, right? Or your distance covered. So you can calculate each area separately and then add them up together and you will find your distance. تمام? يعني you're going to take this triangle, for example, area of a triangle is half base times height. So you write half. What's the base from 0 to 10? It's 10 times height, which is from 0 to 150, which is 150. So half 150 times 10. This is how you do it graphically, and I'm pretty sure the solution is very clear as well in the mock solution that you have online. But I don't want to just solve it in this way. I want to solve it using equations in my method so you guys can understand how you can use the equations as well. All right? Fair. The way to do it using equations. Now we have drawn the graph. Using equations, we don't care about the graph. We care about these values over here. All right. So I'm going to be taking this, copy pasting it one more time down here. Okay. So for acceleration 1, 2, remember the equation, acceleration 1, 2. What was the equation for acceleration? Acceleration in general. What was the general equation for acceleration? The general equation for acceleration is equal to change of voltage over change of time. Very simple. A average or acceleration in general, it's change of voltage, change of time. In other words, it's V final minus V initial over T final minus T initial. And you are going to do that for each and every exact point over here to apply. So if we apply it for the first one, A12 is equal to, then what is our V final in this case? It is 150. Okay, so this is equal to 150 meters per second. All right, or if I want to write it in equation form عشان ما تخربطون, A12 is equal to V2 minus V1. All right, it's equal to V2, V final minus V initial for this range, minus V1 over T2, which is your T final, minus T1. Okay, T1. So if we plug in the values now, A12 is going to be equal to V2 is 150 minus 0, which is our initial, over T2 is 10 minus 0, which is our initial for this part only. All right. So we're analyzing each part by itself, the red line by itself, the green line by itself, the orange, and so forth. So we find out that, let me just move this, make it smaller and move it to the side. Then, so we'll find out that A12 is equal to 150 over 10, which is 15 meters per second squared. And you're going to repeat this step for every single one of these. So we are finished with the first phase. Now let's look at the green line, A23. So we know it's equal to 0, but why is it equal to 0? Let's see. So it's V final minus V initial. Okay, A3 is equal to V final minus V initial. So it's V3 minus V2 over T final, which is T3 minus T2. Okay, T2 is in red, T2. If we substitute the values here, A23 is going to be equal to, what's V3? 150. What's V2? It's also 150 over 20 minus 10. Remember, this is the time T2. We're looking from V2 to V3. So 20 minus 10 is 10, but 150 minus 150 is 0. So it's A23 is just equal to 0 meters per second squared. That's why when you have constant velocity, your acceleration is going to be 0, and this is how you prove it using an equation. And if you want to look at the graph, remember that in the graph, the slope is the acceleration. هني السlope is 0 لأن it's a horizontal line. The horizontal line has a slope of 0. All right, so it is a horizontal line, therefore the slope is 0, therefore your acceleration is also 0. All right, and you're going to keep applying this for each and every one. So now for the orange part, which is A34, it is equal to, I'm just going to write the numbers directly. It is equal to V4, which is 100 meters per second, minus V3, which is 150, divided by T4, which is 30, minus 20, which is T3. And then we're going from 3 to 4. So 4 is our final, 3 is our initial. So our acceleration here is going to be 100 minus 50 is negative 50 divided by 10. All right. So in other words, A34 is equal to minus 5 meters per second squared. And this makes sense. Why? Because we have lost velocity. يعني الvelocity قلت السرعة, فالاcceleration is happening in the opposite direction. معناته this is defining that there's deceleration or acceleration in the opposite direction. So this means that there's deceleration, and even in the question it mentions that then the object decelerates. Deceleration means it is not accelerating, it is the opposite of acceleration, which is deceleration. Okay? And again, we're going to do the same for the rest. So V5, A45 is equal to, I'm just going to write the final equation instantly. So it's V5, which is 300, minus V4, which is 100, over 40 minus 30. So A45 is equal to 300 minus 100 is 200, 200 over, so it's 200 over 10. So A45 is equal to 20, صح 20, yeah, 20 meters per second squared. All right. We found it to be 20 meters per second squared. This is how you're finding the, so the question asks, by the way, عشان you can know, calculate the acceleration in the time interval from 0 to 10 seconds. This basically means from this point up to this point, from 0 to 10. Then from 10 to 20, then from 20 to 30, from 30 to 40, and from 40 to 50. This is what the question is asking for. So this is how we're finding the acceleration for each interval. All right. Let me move this up here. And then, so for the last one, we're going to do the exact same thing. The last acceleration we have for the last interval, which is from 40 to 50. A56 is equal to 400 minus 300 over 50 minus 40. So A56 is equal to 100 over 10. A56 is equal to 10 meters per second squared. And we have found all our accelerations for each phase. When you split up any question, when you split it into this way, it will always be easy to implement. So this is for the acceleration. What about the distances? x12, x23, x34, x45, x56. Again, you're going to be applying an equation and solving. So here, what we did is area under the graph is equal to distance. If you find the geometrical way is easier, use the geometrical way, no issue at all. ولكن, if you want to solve it algebraically, this is the way. So again, I'm just going to copy paste this inshallah for the last time. And then, so we have determined all our accelerations. Let's determine our distances. Remember that x12 is basically same as saying x2 minus x1. زين? It is the change in displacement. بس احنا we're talking about distance. So we're only going to look at the distance part. It is not the displacement that we care about. All right? So in general, x12 or x, when we are writing it in displacement form, so x12 is equal to x2 minus x1, which is also equal to s, all right? Or s1 you could call it. Which is the displacement. Then the displacement is just change in distance. That's it. That's what displacement is. Here, if you remember, this equation was you're going to take the average of the velocities. So it's going to be v2 plus v1 over, or I should say v final plus v initial, v final plus v initial over 2, the average, times the change of time. So T final minus T initial. This is how you will be able to determine your distances, okay? This is one of the equations given. Usually they give it to you just as, it's usually written as V plus U over 2 times T, all right? But remember, this T is the interval time T. It's the time from here to here. For the interval time here is 10 seconds, okay? Because we're going to do 20 minus 10. All right, but me, I'm doing it in the form of final minus initial, and it's better practice this way عشان ما تخربطون بعدين ويا time. All right, especially if for example your initial time was given as 5 seconds and your final as 10. your T, you're gonna know how to find your T. It's T final minus T initial. That's it. All right. So this is just a different form of writing this equation. I'm just gonna move this a bit down so we can solve now using that equation for each part again. So we're going to do x12 is going to be equal to v final plus v initial. So it is going to be v final, which is v2, plus v initial. In this case, it's v1. Again, we're just talking about the red distance, divided by 2, which is the average, because this is the equation. So we divided by 2 times the time, the change in time. So change in time is going to be T2 minus T1. All right. So T2 minus T1. Okay. So x12 is going to be equal to V2 plus V1 معناته 150 plus 0 over 2. Time 2 minus time 1 is 10 minus 0. Okay, so x12 simply going to be 150 divided by 2, that's 75, times 10 is 750. Notice this x12 has to be equal to the x12 you will get from this triangle, the first triangle over here. Okay, so this triangle, and then if I just draw the shapes here very quickly, these are the shapes that you're going to be having. Okay, and then here you're going to have a trapezoid. And then here you're going to have another trapezoid. And then here you're also going to have another trapezoid. So this is the shapes of the areas that you're going to be trying to find. Okay. This is, I hate solving this using geometry, and it's just annoying for me personally. ولكن it is completely fine to do it. So you're going to find all of these areas. So this is area 1, and then area 2, and then area 3, and then area 4, and then area 5. Okay. And then, so you're going to find all these areas. This is area 1. This is your area 2, the rectangular area, right? And this is your area 3, the trapezoids area. Okay. The way you will do it for a trapezoid is you're going to split it if you want. If you don't remember the equation, you can split it and then have a triangle plus a rectangle. You can do the same thing for here. You can split it and you can split it and then just add the rectangle and triangle. I believe that's how they do it in the solution. But again, if you know the equation for a trapezoid, you can apply it directly. And this is area 4, this total area. And this is area 5, which is in brown. Area 5, okay? This full area. You're going to find all these areas and then add them all up, and this will be your total distance. So let's just look at the area 1. لأن إحنا we found now x12, 750 meters. Okay? If we apply this triangle, then if we apply this triangle has a height of 150, and the base of 10. Okay, so this is 10, and this is 150 over here. Over here, this is 150. And then, so if we do the area of the triangle, it's half base times height. If you notice, you get also 750 meters as your answer. So each distance that you find here is the same as finding the area of one interval up here. That is why you just find the area under the graph to solve, or you can use this method to solve algebraically. Again, I'm just going to do a few more examples and then I'm going to leave it at that. So let's look at A23, or X23, I mean. X23 is going to be equal to, again, velocities over 2, we're going to have an average, and then we're going to have the change in time. All right, so x23, where's the velocity final here? It's v3. Where's velocity initial? It is v2. Again, t3 minus t2. All right, so this is minus t3 minus t2. So x23 is equal to, we substitute in the values, it's 150 plus 150 divided by 2 over t3 minus t2, which is 20 minus 10. x23 is going to be equal to 150, 150, that's 300 divided by 2, that's 150 times 10, it's 1,500 meters. All right. And you will do the exact same steps for the remaining distances. So x23, we are remaining with x34. x34 is equal to v4 plus v3, which is 100 plus 150 over 2 times the change of time, which is these intervals are 10 seconds. Okay, so this is going to give you a value of, let me just find this very quickly, 1250 meters. All right, and then again, you're going to do the same for x45. It's equal to 300 plus 100 over 2 times a time, which is again, the interval is just 10 seconds. And this is going to give you 2000 meters. And then finally, x56 is equal to average 400 final plus initial, which is 300 over 2 times 10-second interval, which is 700 over 2, 350, 3,500 meters. Okay. Now that we have found all of these, we're just going to add them all up to find our total distance. Okay. So to find total distance, it's just going to be equal to x12 plus x23 plus x34 plus x45 plus x56. All right, the total distance is just adding them up. Same idea as the areas here. You're just going to add area 1, area 2, area 3, area 4, area 5. So yani the area under the graph here is equal to A1 plus A2 plus A3 plus A4 plus A5. So area 2 plus area 3 plus area 4 plus area 5. It's the same exact idea, right? Whether you do it geometrically or geometrically or algebraically. إنزين? So if we just substitute now the values, this is equal to 750 plus 1500 plus 1250 plus 2000 plus 3500. This is going to give you a total distance of 9,000 meters, which is equivalent of 9 kilometers. And this is your final answer. Did I say voltage? Velocity. والله وايد قاعد ادرس both electrical and mechanical. وايد خربط صاير بين voltage velocity. I don't know how long ago that was, but I just saw chat. Is this clear? Any questions about this? So this is how you should solve any linear equation problem. This is the formulas that you need to know. All right. This is the way you need to apply it. You should always have a starting point and the finishing point. And if the point changes again, you just create a new point and know where your initial and final is for each phase. And then you can just analyze every part separately. And then stopping the recording now.